Let us start quickly by putting what we have discussed in the last class, because that is basically the main reason for us in the last session was finding whether the data is stationary or non-stationary. We can summarize here. So because that all the background of ergodicity and all was basically to understand stationary, why stationarity is necessary, why we are concerned about it. So ultimately, our purpose in practical sense is to find out whether data is stationary or non-stationary, for which we have the certain conditions. Those conditions, again, I'm repeating here. So strict stationarity is not practical. We will not have such a variable where all the distributional characteristics will be same across the different time points. So we are ignoring that part. We are taking the practical part, that is the weak stationarity. So these are the conditions which we discussed. Any series will be weakly stationary if it has respect in constant, variance constant, and autoconvergence depends only on the lag, not on the time. So that's what we have discussed. On the typically a non-stationary series will have a unit root. What is unit root? Already we have discussed into the last session. So moving on, what we told, we take the panel data because it enhances the power of the test, but it has a certain problem. One of the problem was the correlation among the cross-sectional units. So how to take the what we call in statistical sense in the cross-sectional dependence and independence, because whether we are assuming there is the cross-sectional dependence or independence, based on that we will select the different types of unit root. Yes, which we will be going to use in the panel data. So let's first understand what we mean when we say cross-sectional dependence and what are the conditions in which we should be worried about cross-sectional dependence. So in the cross-sectional dependence, what we say independence, this EIT and EJS just simply assume the fixed effect regression model, which you have already done. So once you regress fixed effect model, so what you get the error terms for the every cross-sectional units, isn't it? I'm not talking pool, I'm talking about the fixed effect. So what you get the error terms for the cross-sectional units. Now, if you take cross-section unit 1, cross-section unit 2, if you take those errors, if there is the correlation, well, the I as G is not equal to, that means the units are not the same. Units are different, but there is the correlation. That means error term of the cross-section 1 may have impact on the error terms of the cross-section 2 or vice versa. If that is the case, we'll call that the cross-sectional dependence is there. If it is not there, it is 0, we'll call it cross-sectional independent. So that is the statistical elaboration we have cross-section. What we mean by the common sense, there is no spillover between the units. If something happens in one unit, it is not going to affect the second unit. So you can think of if your room partner is disturbed some way, he doesn't want to study, then he may disturb you. You should also not study. If that he or she is doing, that means there is the spillover or there is the cross-sectional dependence. If he or she is not in mood of the read, but he is not disturbing you, he is not asking you to let's go roam around. That means there is no spillover, there is no cross-sectional dependence. That's what we mean by independence and dependence here. For example, if you have isolated farms, for example, if you are doing anything, let's say agriculture productivity. So you wanted to measure the agriculture effect of fertilizer used on agriculture productivity. So what you will do, you take the number of farms over the period of time, their productivity and their consumption of fertilizer. But one thing is there, one farm you have taken in this area, another farm you have taken in another area. So will it have any effect one farm on the other? No. If it is adjacent, it may have effect. For example, there is over irrigation in the one, then it may have effect on the next one. So that's what it's isolated farms, or we can think of the local markets, which does not get affected by the global phenomena. So then we can have such situation isolated. On the other hand, dependence, when it is not equal to zero, their chances one may affect the other. So maybe due to global shocks. For example, when the financial crisis 2007-8 came, irrespective of which market, every market was got affected. So it was whatever the policy is there, so it doesn't matter, but you got affected. So there is the market recession on every country, irrespective of which kind of policy. For example, if you talk the monetary policy, whether they are using the expanding monetary policy or the tight monetary policy, it doesn't matter, but it would have effect. For example, when we have the Ukraine and Russia war, it whether we have the better monsoon or not monsoon, but the prices of wheat were got affected. So that's what we mean global shock. Then spatial proximity, that means the two can, for example, if something happens in Pakistan, it's more likely we will be getting affected more compared to America because of the spatial proximity. One farm may have chance to get affected by the respective farms. So if you think of when we do the sample, what we say, the sample should be diverse in the primary survey. Why? Because of that. Let us say we wanted to see the effect of education on the standard of living. So what you have done, you have taken 10 people from the same group in the same income level. So it may be not because of the education, but because of the income, they may have the similar kind of standard of living. So what we can do, we can do cross sections of different income level. That's why we are talking, because otherwise there might be the spatial proximity. So common factors could be there. For example, we wanted to see whether, for example, this productivity and agriculture use, how much fertilizer use we will have. Now, let us take, in the Karnataka, there is a very good monsoon season, and you have picked all the farms there for your sample study. So it may be not because of the fertilizer, it might because of this, the common factor, that is the monsoon is there. So you can take the diverse those things. So common factor could play an important role. For example, when we say education and standard of living, the common factor is income level that could play the role. And there could be the cross-sectional dependence. So examples we can think of: European Union stock markets, these have similar culture, similar income level, most of them similar kind of regulations. So it may have the common factor effect. The global inflation could be the one, another example of this. So what we can argue that we can argue this: the independent units are there. If, for example, we have the globalization effect, then it will be dependent units. So now remember here, that means whether there will be cross-sectional dependent or not, it may depend on which kind of problem we are considering. What are the variables going to include in our analysis? It's not necessary it will be always there. It's not necessary it may not be, it will not be always. So it depends which kind of variable, which kind of modeling, which kind of issue you are concerned with that at hand. And why it matters, we are concerned why standard errors. If there is a cross-sectional dependence, but you are not considering it, then the standard errors will be biased and you may get the invalid inferences. Inconsistent estimators if unaccounted for cross-sectional dependence. So requires robust estimation. If there is, then it requires robust estimation, for example, common correlated effects or feasible GLS, not the traditional fixed effect and effect may not work, or even the unit root will see some of the traditional unit root may be problematic if there is the cross-sectional dependency we have. And especially in the globalized world, we have to be very careful. Even we theoretically, we may consider there may not be, but there is. For example, think about the local market example we have taken in the last. Now think of now situation. Is it possible the local markets are also aloof? No, because they have the mobile phones, they have the internet, they can get the information. So if there is a price change in the one market, that may affect the another market also. So that is the situation we have. There is so much situation is that a flood was in Thailand, but the prices of hardware increased in India. Because it's a global change. Because most of the hardware is manufactured in Thailand. In the Thailand, there was the flood last 2-3 years back. The entire the South Asian region has seen a spike in the anything related to the hard disk. So in that case, we have to think about the alternate estimation methods, not the traditional method. So there are the certain CSD tests are there. So these are the CSD tests: PESAR and CSD, Bruce Pagan LM test, Freeze, Q, Friedman. These are the tests. I will be discussing here the first one, PESAR and CD. Why? Because compared to others, it is most widely used, most easy to compute, and in most of the senses, it is more reliable and more consistent. So I'm going to focus on the PESAR and CD. Another thing, others test is the post estimation. But PESAR and CD is possible post estimation as well as the pre estimation. So the post estimation means you have to first regress the fixed effect regression, then you see whether there is the cross sectional dependence or not. But in case of PESAR and CD, we can, without doing that, we can estimate. So I will be trying to explain here PESAR and CD, not others. If anyone interested, that is state a guide you can think read for this test. It is very elaborated they have given. Now, what is the PESAR and CD test statistics? So this is the formula to calculate the test statistics. Here, all this T value of N will come from your panel. Nothing to worry about that, because it will, the moment you form the table, panel data, you will have this information. Only information which is needed is this raw head. So what is the raw head IJ? This is the pairwise residual correlation. Now, which residual? Basically, you estimate the fixed effects regression model. Then, from that, you calculate, from that, you get this residual. Remember, here I'm talking about the residual. I'm not talking about the error term. Residual, and there is a difference between error term and residual. Error term, we are never going to observe. We are going to observe only the residuals. Error terms means this E. Where is the residual means this E. In theory, we talk about the error terms, but in the practical, we never have access to that error term. We have access to the only residuals. So here we are talking about the residuals. So that's what we do. So this residual correlation between I and J. Once you calculate, that means for every pair we'll have. Is it this formula you have understood? Okay. If you have understood, tell me this. Let us say we have the 3 cross-sectional units. How many raw IJ will have? So 1, 2, 1, 3, 2, then 1, 3, n into n minus 1 divided by 2. That's the basically formula. N into n minus 1 divided by 2. That's the basically formula we'll have. So remember here, I'm talking correlation between 2 pairs. So every 2 pairs you have to select. It's not that 1 into 3 and 1 into 2. So 3 and into 2 we have to also take. So every pair's correlation we have to find out. And what are the features and limitations of this test is that features valid for NT tends to infinity or of any order. One of the critical advantages of any order, whether n is larger than t or the t is larger than n, it does not make any consequences for the PESAR and CD test. Robust to heterogeneous slopes, that means you are assuming that the raw I, the structure for every cross-sectional is different, which is more realistic compared to assuming a common unit. The structural break is there, even then it is more. Weak factors, even there is the minor correlation that can be captured using this. The standard normal distribution, that test statistics follow the standard normal distribution so that it is easy to create the test statistics. However, the certain limitations we have, raw IJ when we have alternate signs. Let us say we have the 3 cross sections, 1 and 2 have the positive correlation, 2 and 3 have the negative correlation, then it has lower power in such situation. Or t is very small and n is very small, then it is clears the problem. Requires T is more than 3, N is more than 3. Why it is most widely used? Because nowadays we have not the dearth of data. Basically, we have problem of immense data. So now we don't have issue of T and we don't have issue of N. Mostly we will have enough T and enough N. And that's why it is most widely. It's very easy to compute. And assumes weak dependence. If there is if there is strong dependence, then it becomes little low power. But remember again, it is the cross section. So in certain cases only we can think of the strong. Otherwise, there will be correlation, but mostly weakly. Yes, the monetary policy of US can affect the Indian inflation, but it's not that it will be quite strong. So reading the results, if we get the estimate, so reading the results, how we'll get this is the let us say CD status 8.73, p value is 0. Null hypothesis, there is no cross-sectional dependence. So the decision rule will be this. I'm again putting absolute value of CD, absolute value, if it is more than 1.96, reject at the 5%, if it is 2.58, it reject 1%. Now let us say here we have 8.73. So what is the decision you will make? Is there cross-sectional dependence or there is no cross-sectional dependence? There is the cross-sectional dependence. Then I will give you the rule of thumb, which will be easy to do for. So for any test statistics, remember this. If the p-value is closer to 0, reject the null. If p-value is closer to 1, accept the. So that's you can think of for any test statistics. This is the same criteria we have. So so what conclusion is strong evidence of cross-sectional dependence if the p0 is less than 0.1. Here it will be basically no cross-sectional dependence, because here we have the null, no cross-sectional dependence. So that means there is cross-sectional dependence is there. So what you answered just before that? Most of you just before what you answer. There is the cross-sectional dependence. So if we have significant cross-section, the need robust estimation methods. You have to think of the alternatives of the traditional methods which we quite often use. So we have to be careful about it. Then the first generation unit test, where we assume there is no cross-sectional dependence, there is the cross-sectional independence. Among that first generation unit test, we can think of the 3 types. One, which assumes a common unit root process for across all the cross-sectional units. Second, allows individual unit root process to be. So the raw I may be the different for the different cross-sectional units. Third category, where basically combines the p-value for individual tests. That's the 3 category. So here I'm going to discuss one from the first category, second from one from the second category. Third is basically nothing but the taking average of the individual unit root test. So that I'm not going to discuss here. So let us first talk about the first thing. So this is one of the most widely used because it has certain advantage. So here say alpha I rho yi t minus 1 theta is g. So basically what we wanted to test what is the value of this rho I, because that will tell us whether the series is stationary or not stationary. So what we are assuming here, we are assuming yes, it may change for every cross-sectional units. However, here we are assuming every cross-sectional unit have the same coefficient. That is how the previous value is going to affect the present value. That is same for every cross-sectional unit. You can think of this way. We have the marginal propensity to consume, which what we say? It says that if your income increases, your consumption will increase. Here, what we are assuming for everyone, if we am giving 100 rupees more income, everyone will have the same expenditure, the 70 rupees. Is it possible? So that is little away from the reality. It's not some may spend 60, some may spend 40, some may. So here we are assuming that relationship is same across the cross-section units. So hypothesis is rho is equal to 0 or rho is greater than 0. If rho is equal to 0, that means there will be unit root And if the raw is less than 0, that means there is stationarity. That's what we have. Null is there is the unit root. Alternate is there is no. Remember here either all of that is non-stationary or all of that is stationary. So the test status is TB is raw head divided by standard error of. That is the standard formula of any test statistic you might have studied from the linear regression model. You can think of any test statistic. That's how we calculate the coefficient value divided by the standard error. That's the standard process we have for any. The same thing here we are doing, but it has certain issue. That's why we have panel data, a separate branch than the time series data. Otherwise, till here, nothing has changed. Same thing. But here, this we may not be able to use. Why we may not be able to use? Because we have different cross-sectional units, not uniform time series here. So this statistic will be biased. Why it will be biased? Because presence of deterministic components, that is the fixed effect, that is alpha I. For every cross-sectional, we have different alpha. In the time series, we have only one alpha. Here we have different alpha I for the different. Another thing, there could be serial correlations, residual, that the cross-sectional dependence could be there, or the finite simple distortions in the panels. In the panels, that whether how the n and t moves to the infinity. Whether n by t moves to infinity, n is moving faster than t or t is moving faster than n, that may affect the adaptive behavior. So therefore, for this bias, we have to make it certain adjustment into this statistic. So how we do that? So if we use does not follow the normal distribution, if does not follow, that means our inference could be misleading, we cannot take. So to make it, so force it must follow the normal distribution. We'll make certain adjustment here. So what are the adjustment we are making here? The TB star now adjusted here. TB minus this mu star T and the sigma star. And this mu star T and the sigma star T, basically, we calculate from the given data. And once you make adjustment, now this follows the normal distribution. Now we can use this to calculate the decision. So mu star bias adjustment mean under the, so mu sigma star T scaling factor standard base. So how we calculate in a minute, it will come when we say the steps of calculating this test status. Just simply remember, yes, some adjustment we are doing, mu star T and sigma star T, we are calculating given the data. Corrects for finite simple bias in source valid inference. This accounts for the fixed effect on deterministic trends. That's why we are testing this. Now, what is the procedure? This is the procedure we do. Now, remember the theory. Theory was simply then we will estimate the raw and we'll do that. What is the procedure? Procedure is different than. So what is first lag length for each unit will decide what should be the lag length of delta YT minus. The first lag length note, the second lag length. Just for making the, there is no serial correlation. If you get the lag length, we have to delta YT minus I we do. So for that term, we have to calculate the lag length. In the first, only we have raw YT minus 1. So YT minus 1, first lag. There is no issue. The second part, we have the issue. For that, we will have. Then regress delta YT and YIT. That means we will have the two regressions equation. In the first regression, delta YT regressed upon the delta YT T minus J. So difference regress on the lag of difference. In the second case, what will regress? YIT on the lag difference and this. These are the optionals, whether you wanted to have alpha I time trend. These are the optionals you have, whether you want to have or not. But one regression equation will have delta YT regress on the first difference, second regression YIT on the first difference will regress. Then that means we'll have the two types of residuals, one PYT and BYT. One from this regression and another from this regression. Then this standardized the residuals. So basically, when we do the standardized residuals, that's basically mu star T and sigma star T we get. Then estimate the pool regression equation, this EYT and the PYT. Now we are testing whether this raw is equal to 0 or not, which will be equivalent to testing the raw in the first equation. So the testing procedure is different there. Both will be equivalent here. So we test this and take the inference for that row. That's how we do that. So the reading the results, let us say we have this scenario, then what is this is the critical values we have, and this is the this. So if this is given, so what conclusion you will make? This is the decision rule here, and this is the data output you have got. So what decision you will make? We have to compare this statistics from the critical value. So here we have, you can take either of these. When we have only constant, we have this critical value, we have constant and trend, we have this critical value. So either one you pick. So what we have to do, we have to compare the statistics with these critical values. So if you compare, so what decision you will make? Yeah. So null is given here. What was the null? The data is non-stationary. So are we going to accept or are we going to reject given this result? What you are claiming here, if T star B is less than the critical value, if so, if less than the critical value, then what will we reject the null? So minus 8.73, is it less than the minus 2.3? Let us say 1%. Is it less than or more than? So 8.73 is more than the. It is a minus. So obviously 8.73 is less than the 2.3. So why bringing I brought this? Because in some textbook, they will not write like this. What they will write, the mode of 8.73 should be more than the mode of critical value. Or in some textbook, they will write that if it is more negative than the critical value, we will reject the null. So all three means the same thing. Either the absolute value of the statistics should be more than the absolute value of critical, or you can say that this test statistics should be less than critical value, or you can say test statistics should be more negative than the critical value. If this is a scenario, that means we'll reject the null. Or one of the easiest other way, just look at the p value. P value closer to 0, that means we should reject the. So that means the data is stationary or non-stationary. Panel is stationary. Panel is stationary. So that's why I have written the large negative values. It is stationary. So conclusion is strong evidence of stationary because P is less than 0.01. Absolute means taking the mode. We are concerned about the. It will be 8.73 and it will be only 2.32. Then in that case, it is more than the 2.3. Yeah. If you are taking absolute, then it should be more than the critical value. So here the failure to reject a null hypothesis does not imply all series have the unit roots. We are not implying that some of them have the unit. Some maybe still, which is that basic. Now, what are the limitations we have? Here the null is all series have the unit root because they assume the same pattern. All series is stationary. So they are dwindling only this. Either all are stationary or either all are non-stationary. Assumes common unit root process, allows for the individual effects. Alpha I includes time trends. That is the point we have. What are the limitations? Assumes cross-sectional independence. One unit does not have any effect on the other units. That's what you are assuming that. Requires homogeneous autoregressive coefficient. That means the relationship is same for across the units, which is obviously a quite restrictive assumption here. Then alternative hypothesis, again, too restrictive. What we are assuming, either all of them is stationary or all of them is non-stationary, which is in diverse panel may not be. So therefore, that means we should consider the more closer to the reality, that is the heterogeneous test. So what is the heterogeneous? The real world panels often heterogeneous in dynamics. In Basaran, this IPS test, he has addresses this limit. So what he does, he allows the different AR work coefficient for every coefficient. So basically what he does, that instead of assuming raw, he's assuming beta I. So the value of beta will depend whether you have cross-section unit 1, cross-section unit 2. Again, he assumes it could be some have the same, but not necessary, not compulsory. It may be the same, but they are assuming. Only the difference from the first equation is this equation. Instead of raw, a single coefficient for every cross-sectional, we have different coefficients for the this.
So we call them second generation.
No, that will come later. So here we have the null hypothesis, beta I is equal to 0 for all I. That is the null hypothesis, that all have the unit roots. Where is changing? We are changing here beta I is 0 for some I. Remember here. Again, here what we are assuming? The same null. All of that beta I is equal to 0. That is the unit root for all. But alternate we have relaxed. What we have relaxed is some may be stationary or some may be non-stationary. So when we say that data is non-stationary, we reject that. We are not rejecting that all of them is non-stationary. We are rejecting some may be. So the individual interest rate alpha I, unit specific trend delta I, heterogeneous lags pi, different beta I across the units. So every individual specific effects we are considering here. So critical difference is that H1 allows some, not necessarily all, series to be extended. So here the null is the same in LLC here also. Only alternate is different. So what is the process? Compute the individual ADF test statistics. So here we are running the regression for every cross-sectional unit. For every cross-sectional unit. Then average the T statistics. Simple way, 1/1 summation n by standard using norm. So then we standardize this test statistic using this value. So here, these are simulated moments. Therefore, for this critical value will depend on every time. For example, here we have listed the critical value. Here we cannot list it because it will come from the simulation. And simulation will change always depending on the number of generations and the time period. How many number of simulations you are giving, that will depend. So the critical value will be dynamic. So for example, here we have this significance level. So these values are dynamic, simulated. So the same we have as we have done here. So here we have written critical values are negative. So we can say large negative value that will reject a non-stationarity, that is reject a null hypothesis. So if this is the case, what will be the conclusion?
They're rejecting them.
Is that stationary or non-stationary? That's stationary. So reject the null evidence of stationary in at least some units. Whatever allows heterogeneous dynamics, more realistic H1 than the LLC, because in LLC, what we assume, everyone follows the same pattern. Here, at least we are allowing not everyone follows the same pattern. Then high power for the mixed panels, the simple computation standard normal limit requires a cross-sectional independence. Again, the first condition case. The lower power when the small l and small t small or few stationary is sensitive to the lag selection. Practical recommendation, what I suggest from the literature is that always use trend if series grows over time. Then in that sense, the sensitivity of lag selection may be reduced. Then choose lag via AIC and SIC and always try to change 2-3 applications at least by changing few lags. Take cross-sectional dependence first. If the cross-sectional, then doubt the result here because we have assumed there is a cross-sectional independence. So the comparison of other tests, this is the basically here. So it says the common AR coefficient all is non-stationary, all is stationary. Here, all is non-stationary, some are stationary. Fisher ADF again heterogeneous, and Hadley again the homogeneous, some are non-stationary. This is similar to the KPSS, where we are assuming data is stationary. So these are the basically comparison. Basically here two types, whether we are assuming heterogeneous, whether we are assuming non-heterogeneous. So all this is part of the first generation test, where we are assuming that there is the cross-sectional independence.
Please explain the
Which one? Yeah. What I'm getting with the constant plus trend, whether what should we include? I'm here suggesting that if your series is trending over, for example, if you have taken GDP, so obviously GDP is trending over. So growth rate may be negative or positive, but you will see GDP data is always increasing. So in such cases, you should include the trend if your series shows such kind of behavior. Total, yeah, not necessary, because total factor productivity it's not always follows the trend.
So if I'm working on GTFP, so I estimate TFP also. If I included trend, I got better results.
Yeah.
For the coffee.
See, you have other variables, even GDP or other things.
Yeah.
That's for that reason you can. But if you think, if you're asking directly for the TFP, so TFP may not follow the trend. Total factor productivity may increase, may decrease. But per se, it may, because it is derived from the GDP. So GDP is following trend. That result may be reflected on that. Then this.
So, when to decide what test, sir?
That I will come at the end.
Okay.
Because there is more tests we have. That I will give you at the end. So take home points widely used for heterogeneous panel unit root testing, IPS, not LLC. If you believe your panel is heterogeneous, the relationship may be different for the different cross-sectional units. And remember, it depends on the situation, it depends on the problems, what basically you are doing. Superior to LLC when units have the different dynamics, simple implementation, average always report, deterministic terms, whether you have included trend or not, whether you have included intercept or not, while reporting the results. Lag selection method, which method you have used for the lag selection, AIC or SIC, because this result is very sensitive to the lag. So if you have used AIC, it will have the different lag. If you have SIC, you have the different lag orders. So you must say which method you have used to choose the lags. The second standard statistic in the p-value you should report. Now, but the Baltagi says that in applied works, the IPS test should be preferred over the LLC test when there is reason to believe that the persistent parameters differs across the units. So half of the answer you can get here. If we compare LLC and IPS, so which one I should choose when I should choose. But I'm telling you, this is half answer. Half you will get it later. Now, the second generation. Heterogeneous panel means we are assuming that the relationship, the data property across the cross-sectional unit, it will be different. There is no, see, for example, if you take the GDP of Indian states, if you say all the states GDP we are taking, so do you believe the same process will be followed in every GDP? No, there is a clear dichotomy of the South and North. So whatever the GDP structure will be of the South may not be the same in the North. So you will have, isn't it? So in such cases, assuming the common is quite problematic. So we can think of that way. Now let us say if you are doing some school education research that I'm taking schools only from one state. So there we can assume it might be follow the same pattern because the policies are the same, cultures are same. So school in the same state, in the same vicinity may have the common unit, isn't it? That's how we say heterogeneous.
So is heterogeneity same as cross? Different concept.
Heterogeneity is the different, but this might be one of the reason for this cross. If there is a common, then there is the more chances of cross-sectional dependence. It is heterogeneous, there is less chances of cross-sectional dependence. But two are the different concepts. And the cross-sectional dependence could be not because of this. For example, GDP of every country may have the different structure, but there is some global financial crisis that may have created the problem of cross-sectional dependence. So the second generation test, first generation test, they use cross-sectional independence. But now in this world, where we have the global economy, say shocks, financial contagion, spatial spillover, in such scenario, integrated world where we may have such kind of, assuming there will not be cross-sectional dependence, is really a very restrictive assumption to me. So if we have such cases, then we have to rely on the second generation test, because if there is a cross-sectional dependence, and if you are ignoring, then there will be size distortion and power loss we will have. In such cases, we have to think of the second generation test. Second generation tests are the two, one the pressure and shifts and the buy and there are others few, but most widely and commonly used these two. The pressure and shifts and the buy and NG. Pressure and shifts the same ADF which we have discussed, the same structure. Only thing for the to take account of the cross-sectional dependence, he includes one extra term into that equation. It is simple, you can think of. The same as we have discussed, the same structure will have. One more term he adds, which depends on the cross-sectional dependence. I will discuss all those equations in simple terms, that's all. By an NG, basically what it says, there is a global shock because of the cross-sectional dependence. So let's do away that. Remove that effect. For example, let us say what we have the cross-sectional dependence because of, let us say, monetary policy. So let us remove the effect of the monetary policy. Let's have the effect of state fiscal policy. See, in India, what we have, states have the fiscal policy, but the monetary policy there is the common. So this is the common factor. So let's remove that effect. That's how the second is relying on that. Now let us go in the detail what we have. Both methods explicitly model cross-sectional dependence while testing for the non-testing. That's the basically advanced. That's why we call it second generation test. So for example, here shifts cross-sectional, what we have? Delta Ig plus this theta Ik. So if you remember the first line, what we have discussed in now. Here, what we are adding, the second line, the first term we are adding. So this cross-sectional average we are taking. So this YT minus J, that is now what cross-sectional average we are taking, we are including it here. That's only addition we have done. So augmented ADF unit with YT bar T minus 1 and delta. So that's what we get. Augment means basically adding something, isn't it? So here what we are adding the cross-sectional average. That is Y bar T minus 1 and delta YT bar. This YT bar is nothing but the cross-sectional average. So accounts for unobserved common factors, heterogeneous coefficients, no need to estimate the factor because in the second we have to estimate the factors. So this is the test statistic we have where TI the states for the BI for the what is this cross-sectionally augmented decoupled. Why cross-sectionally augmented? Because we have taken cross-sectional average, added that term. That's why we call it cross-sectionally augmented decoupled. So that we have done. Null hypothesis here is that beta I is equal same is 0 for all, that all units are non-stationary. And we have for IPS the same thing. For I, some unit rules, the same thing. Only how we calculate the beta I, from where we derive that beta I, the structure of that equation has only changed. Other things remains the same. So here the kit can be simulated by PSR and 2 depends on the N and T, whether we have added the deterministic term or we have not added. Depends on all that. Now the bi-NG panic, it's very simple. Basically, what we are doing here, we have this particular series. We are having one thing. One, the common factors and the idiosyncratic. So, for example, the common values we are doing away, then what will remain? If you are taking away the common values, what will remain? Individuals. So that we have named each idiosyncratic error terms. So once we take away the common, we left with the individual effects. So that is known as what we call is idiosyncratic error terms. So we have this. So this is basically individual unit components. And this is the common factor. How we calculate this factor loadings, that depends on the another technique what we call the PCA or the principal component analysis. Common and idiosyncratic non-stationarity. So here we have it. So how we adopt demean or the detrain the data in this area? What is demeaning? What do you mean by the demeaning? Yeah. For example, we have Y. Take the mean of the whole series, then deduct that mean. So that's what we mean by the demean. Either you demean or detrain. How will detrain? In the first, we have talked about how we detrain. You regress the equation on the train, you will get the estimated value. Isn't it? That estimated value you deduct, that is nothing but the detrained data. Then the compute the idiosyncratic component here. So this is the common factor we deduct from the original variable. What we left with, that is nothing but the idiosyncratic component. Then test the factors with the ADF type of test here for both, for the first component, for this second component. So here the null hypothesis we have, the common factors are stationary. In the second, we have the idiosyncratic components are non-stationary. That is, we are having. So here we have the two null hypothesis. Basically, for the one series, we are doing two tests, one for common, one for idiosyncratic. So two null. Alternative again the same. Now, how we make this happen? Because it could be that the factor components is stationary, but the idiosyncratic is non-stationary. It could possible that factor component are stationary and idiosyncratic is non-stationary. Then how will combine such? So here is the decision. The common factors. So if it is stationary and it is also stationary, that means whole panel we can claim is stationary. If it is stationary, however, it is non-stationary, that means panel is non-stationary. But only thing here, the non-stationarity comes from individual characteristics, not because of the common factor. We can find out which is the source of the non-stationarity. So that is the comment. That simple you can remember. Any of these is non-stationary. That means your panel is non-stationary. If both are stationary, that means the panel is stationary. That's how we calculate. So what is the way of how we do that? How we decide that? So this is the structure basically. Run the panel test the common factors first. So first you test the common factors. If it is stationary, then test the idiosyncratic error terms. If it is non-stationary, then once we can conclude panel is non-stationary. That's how we. If it is stationary, go to this. If it is stationary, then panel is stationary. If it is non-stationary, we can claim panel is non-stationary. If the first part is itself non-stationary, we can claim data is non-stationary. That's how we can do it. But usually, how the people do, they will do test for both. Now, which one I should use, whether the SIPs or this ING, which one is we can use? So these are the different criteria we have to evaluate which one is better. So if you see the dependence structure in the SIPs, we are assuming weak cross-sectional dependence. Here, a strong factor structure could be possible. The common factor is quite strong. You can have the strong cofactors. Implementation, it is simpler. Here, it is completely intensive. Why? Because first you have to do the another thing, that is principal component analysis. From that, you have to find out which is the common factors. Then you have to run the unit root test. Here, we don't have to do all those things into the SRC. Information gives only stationarity test. Here, it says common idiosyncratic roots, whether it is the common factor or idiosyncratic factor. This is again statistical jargon, you can say, how it matters in the empirical work. For example, suppose I wanted to use purchasing power parity hypothesis to test that. What is the purchasing power parity hypothesis? This is not econometrics, this is economics. All of you know economics. Purchasing power parity hypothesis.
We can buy.
So
It talks about basket of goods.
Yeah, you can think of this way. If a haircut costs me here in India 200 rupees, the hair cost, the same haircut cost in US will be same 200 rupees. But there we will be paying in terms of dollar. So we're not going to pay $200, but we are going to pay some cents. Is it true? If that is true, then why people try to smuggle Apple phone from US to India? Have been same. Then why they do that? So the triple purchasing power parity says that in short run there could be deviation, but ultimately in the long run it should be the same, isn't it? That means the exchange rate, the price differential between US and India at the end should follow unit root or non-unit. It should be a stationary. That's how the concept of unit root we use. So that I will answer in detail later when we'll talk the first slide. So,
Reality.
so in the long term doesn't long term. So I will tell you, and see, this is not only economic. Have you imagined that some people comes from the urban area, the large city, to the villages? In the beginning, he spends a lot. Have you noticed that? In the beginning, he will spend a lot. Or the some US return, in the beginning, he will spend a lot. How do you think why does that? Because he thinks this is cheaper. But after some time, if you notice him 1 year, then he stops doing that. You know why? Because his salary now in here becomes comparative. So now his behavior becomes same as the Indians. Consumption rate. So that's what we talk purchasing. In short run, it may deviate, but in the long run, it must be the same. Otherwise, the smuggling will happen always. Uh, so that's the basically we are talking alternatives. However, here this common idiosyncratic roots. So why I went there? For example, suppose I wanted to examine this whether this financial crisis have impacted commonly structure, have created the common structure in the financial market, the financial structure across the world or not. So that means the common, then why just examining the some indicator of the financial market will not help me, because I have to see whether it has created common structure and that is stationary. That means I have to bifurcate that series into the common trend and idiosyncratic trend. And that can be done using the IN binary. So if you have such kind of analysis, then we'll prefer this. Then just special and shifts will not help you out. So it depends on that. Then factors can be implicit via averages. Here, explicit factor extractions using the principal component analysis we do. Robust to R means specifications, to R choices. What is the R? So here we have taken robust to R means specification, sensitive to R choices. What is that? What is that R? So this R basically, this sensitive R, is to say how you change the lags. That's earlier also. That will have effect on this. They have used the term R sensitivity. But if you change the lag, it will have the entirely different results here. So that's the basically we have choices here. Empirical recommend default for the panel testing with CD, whether factor structure is theoretically important or not, depends on that. If you say that you need the common factors and these factors separately, then it is better to go to binary. How you will give directed, it will be directed from what you wanted to do at particular point of time. So best always test for the cross-sectional dependence first, using the PESAR and CD test. If CD present, use the second generation test. That's what we can decide. For structural analysis, prefer by NG if you wanted to see structure and the common factors. If for the routine testing, prefer the shifts. That's how we decide. Then the structural breaks in panel. Why we are basically talking about the structural breaks? Structural break, again, you can take the help to understand the importance about structural breaks from the behavior of observing the behavior of in and around. Have you seen that most of the students' behavior changes in the second semester? Whether it's a food habit, whether it's the clothing, whether attending the class. In the first semester, they will be very, especially the rural guy, will be very scared, very disciplined. He will come at exactly 8 o'clock. When the second semester, so what happened in between? There is this, that changes is nothing what we call the structural shock. Or one guy, a very young age, drives bike crazy, he meets with accident. After that, you ask him to drive bike at 80, you take the bike, I will go by auto. So that's the structural change. That's what. That means, it's either the behavior changes or it makes the shifts. That's the structure. So in the common life, when we can see the importance of a structural break, if there is for example, take the example of students. That behavioral change will have impact. That his consumption pattern will change, how he consumes time, that will change, how much he has the productivity, that will change. So structural break do have impact, isn't it? Similarly, structural break have the impact here in the data also. So what is the structural break we haven't understood? So break sources could be because of the financial crisis, for example. It could be because of the policy shift. So policy has changed, that it will that changes. Or technological disruptions may happen. All this may create the break. Break, when we say, that means it could be either this kind of shift. So this is the break in intershape. Or we can have another break where from this exists here. After that, it becomes not like this, it becomes like. That means there is the break in slope. So break could be in intercept, or break could be in slope, or break could be in both. And it has a huge impact on the whole unitude. For example, what we are assuming, either we assume the individual common unitude test, individual unitude structure, or we use the common. But what we have assumed, if raw I, raw 1 is for cross section 1, but it is same for across the time period, isn't it? But here what is happening? It is not remaining same. That means the data is changing, but we are assuming it remains same. So will we be able to capture the dynamicity of the data using those unitude tests? Not be able to. So that means non-stationarity means your mean, variance, covariance depends on time, isn't it? That's non-stationarity. So you use those tests and it is saying you are finding that data is non-stationary, isn't it? But the problem is that is non-stationary, does not comes from the data generating process, but comes because there is this structural break. So you are testing this part. Obviously, this mean will be different and this mean will be different. So this is not because non-stationarity. This is because there is the break. So that's the point. If there is a structural break in the data, then you will have misleading inference. Though the data is stationary, but you make it the result data is non-stationary. And whether the series is stationary or non-stationary, entire conclusion can be changed. Isn't it? For example, triple P approach. For example, interest relationship between interest rate and short-term interest rate and long-term interest rate, it may change. What we call the expectation theory. For example, if you take from the finance, the relationship between what called prices and dividends, so that may change. So it has the huge impact if you ignore this. And that first, the Pedroni told about this in 1998. you must not ignore the presence of structural break, whether it's a time series, whether it's the penalty. So matters breaks in trend or mean can mimic the persistent and cause the false acceptance of unit root, loss of power in the stationarity test. That's what we have discussed here. So types common break dates across the every unit, the same at same point of time, everyone has them. As if claiming in the fourth semester, every student has failed in the third semester or in the same paper. That's what is structural break. Unit specific, yeah, some may be failed in the subject one, some may be failed in subject two, some might have failed as semester one, some might have failed in the semester. So that's the basically we can say. The biparallel and the multiple breaks and Karavis and Salis 2014. This is to examine whether there is the break or not. This is the unit root test which takes account of presence of structural. What the point? So this is called unit root test. This will tell you whether there is the structural break or not. If there is a structural break, then we have to think about the way how we can incorporate that into our unit root testing. And this Karavis and Salis, he says that they have developed, basically they have used same algorithm of this incorporated into their testing process. And they do the both at once. They test unit root in presence of the structure. So this I'm not going to discuss because it remains the same as we have incorporated the cross-sectional dependence. Similarly, the structure we will discuss here, they incorporate into the unit root test. That's all. Nothing is there. So let us talk about, so here the undetected breaks bias unit root tested towards the non-rejection of the null. So here biparent breakpoint estimation. So basically what they have done here, they regress this series on what? Only on the time trend. See, forget about this for a moment. What we basically are doing, we are regressing the series on the time trend and the constant. That's all. No variable we are regressing, nothing we are doing that. Only we are regressing the variable on the time. Why we are doing that? Why we did not regress it on the some other variable? Why we have not regressed on the constant? Why am I asked? Because this answer comes very logical. It's not the statistic or something. The break will happen when the time. So that's why basically we give the reference of time so that they can detect whether there is the break or not. So this is the, so this part YIT mu I and BIT and this UI is the basically very common. Only thing now let us focus on this and this. What they do basically. DK1 is equal to 1. Well, if there is the break, so this indicates the presence of or absence of break. It simply says that if there is the break, let us say if we have the data of 1990 to 2000 and there is the break in 1995. What this term says that then after the 1995, we will create a dummy whose value will be 1. And before that, whose value will be 0. That's what they do. That I'm going to that point. So here, so this thing. Then here it is basically train shifts the dummy, so changing. So this is interesting. Now train shifts means here what we do 1 multiplied by t we are putting now. So we are multiplying 1 into t. So 95 1 that means slow. Sorry, intercept. If now 1 into the what is the time point at that time? So it is 1 into 1. It is the second time period 1 into 2 third time period. So that means that value of this dummy variable will depend on the time, isn't it? So this will represent the shift from here to here, and this will represent the shift from here to this. What the point? So that's the basically we do. So this is the unknown break test to be estimated. How it is estimated based on this asymptotic. So once you estimate this will now, what is the logic behind it? Now, if really there is the break, then what we'll have? Now we will have the value of du. And if we have the du, that means the coefficients of du should be significant, isn't it? If there's a break, then the coefficient of du, this delta ik should be significant. What you told the multiple structure breaks, that's why we have this multiple dik. It could be d1, then d2, d3, and so that means the delta I should be significant. If there is the break in the trend also, that means this gamma ik should be significant. If these are significant, that means there is the presence of break. If there is not significant, that means there is no presence of. That's how the basis of the testing is. What is the estimation process we have? The global minimization of SSR. What is nothing? Sum of squared regions. Both. It could be both. Yeah. It could be both. It could be one. Now, to explain this, simple I will use. How many people have heard the name of Chow test? Chow test. So that is basically nothing. The Chow test we are doing here. Only thing in the panel fund. So in Chow test, basically what we do, we have a data, let us say 10 years data. On the 5th year, I'm claiming that there is the break. So what basically we do, we estimate the first 5 years, then we estimate the second 5 years. Then we see, compare the SSR, sum of squared residual of the first part, the second part. If both are different, then we'll say there is the break. If both are the same, there is no statistical significance, then we'll say there is no break. That's basically same thing here do. Now what we are doing, the globalize. Basically what we do, we take, let's say, first 10 observation and the last 90 observation. Then we take first 11 observation, last 89 observation. 12 observations. So that way, how we do dynamic programming. That's why when you do this test, it takes a little bit time because it calculates all those regression equations and compares. So whichever is minimum, and that is if that is significant, that they say. So what basically they do? So whichever is minimum, they take, okay, this is the probability. Then they create a dummy as per the first equation. Then they regress that. Now, if they see the coefficients are significant, that means that is structural break significant. That's how it is being done. Then the sequential F test. So let us say one we have done, we have found it is significant. There could be more than one. For that, again, they run that one, then the first part, the second part, then again, they sequentially test the first, second, third, fourth. So first, let's see whether there is the break. Once they is done, taking the reference point, now they see, is there any more break? If there is any more, which one is the significant? For that, they see the F test. So that's how we call the F sequential test. So there's a say how we do no break versus at least one break. We got one break. Now one break versus two break. Let us say we got the two break. Now two break versus more than two break. That's how we say the sequential F test. So the problem is regressive. Then this is the structural break why we have. There is the one test, structural break unit 2 test, which will do in the hands-on. Theory, I'm not going to explain. Only thing, see what basically he has done. He knows that how to will get this, isn't it? They have incorporated, augmented this, the unit 2 testing equation. So if this is the significant, then they calculate the test strength. That's much. All others are the same thing. Same ADF we have. Only this term they have augmented in that, so that if there is a present structural break, then it should be. So this is up to here. We have talked about the unit 2. We have talked about unit 2. Now, if there is a unit 2, let us say, if we are using regression, that means there will be the problem of the spurious regression, isn't it? We will have the problem of spurious regressions. Doesn't it mean we should entirely negate the relationship between the two trending variables? For example, it could be that there is no relationship between milk production and the rainfall. It is because both are the trend. So that the GDP and investment, they are also the trend. So investment also over the years increase. GDP is also over the years increase. So should we call that there should not be relationship between GDP and investment? Then how to detect that relationship? So for that we have the concept of cointegration. For that we have the basically concept of cointegration. So what is the cointegration we have? So this is the task I'm giving because this is I have done. It's very interesting. I think C might be knowing because I have shown this into my that financial econometrics course. So if you run this, you will see entirely very interesting the example of spurious regression. So the cointegration, what is the cointegration? It says that two or more I1 variables. That means the non-stationary series or integrated order one series are cointegrated if there exists a linear combination of this series which becomes stationary. So if we have a value of beta different than the 0, and then we get this epsilon t and it follows a stationary series. So yt is non-stationary, xt is the non-stationary. But we have linear combination. Linear combination means there should not be power of any power on the beta. So we have any value of beta in such a way, we connect these two and we get it epsilon t, which follows nothing but the stationary. If we have such kind of value of beta, which have this kind of relationship, then what we will call, there is the cointegration between xt and y. Got the point? It could be, see, minus is general. It will depend ultimately what is the value of beta, isn't it? If the value of beta is positive, it will be negative. If the value of beta is negative, it will be positive, isn't it? So have you understood the concept of this cointegration? Lot of no. Okay, let me move ahead, then it will be easy to understand. Economy mean long run equilibrium relationship, short deviation possible, but mean reverting. Observation that we have done now. So it will be easy to understand from this. What is you can observe? By the way, this is the Amazon River. So what we can observe, this two series. So two banks, I believe the two series. So you can think of here, this series has moved this side, isn't it? This bank has moved this side. There's a larger gap you can think, isn't it? Here, this has moved this side. Similarly, here, this side we have moved. So here the width is this, but here we have the larger width, isn't it? But if you take the average of the width, you will find it is almost same. So that average series, the difference of these two series. So this particular series could be non-stationary, isn't it? The other series may be also non-stationary because you are changing the variation, you are changing the mean will be different. But now if you take the difference of these two series, that is nothing but the width. That width is most probably it is stationary, isn't it? Average. Now if you take the average width, the difference between two. So what you can observe, here it could be positive, but here it could be negative. Here it could be positive, here it could be negative. So overall average of width will be nothing but the same. So if you relate with the stationarity concept, that means both this series is non-stationary. But if we have combined that series, we got by making difference one series, that series looks it should be stationary, isn't it? Up to some it's now it should be easy to understand. So that's the nothing but the concept of cointegration. The individual series could be non-stationary, but their relationship will be stationary. If we have such, that means that relationship is true, it's not spurious. That's how I told that GDP and investment. That's why we say that if the series are contiguous, then there is no need of making it different stationary. There is a huge debate. Early 60s and 1960s and all, no people used to do unit root test for the vector autoregression. The reason they gave this, if they are contiguous, there is no need. It will not be the problem of spurious regression. If they are not contiguous, then only we will have the spurious regression. So still you will see few paper which is written by the classical people, old people. They do not perform unit root test while they are estimating vector autoregression, because they believe there will be the cointegration, so there is no need to do that. The new people, what they do, if there is a cointegration, we will not estimate where, we will go with the V's. So that's how the logic goes. So that's the cointegration we can think of. For economic examples, for example, interest rates, short versus long terms. Short term, there could be variation in the interest rate, but ultimately it follows the long term path. So short-term interest rate, non-stationary. Long-term interest rate, non-stationary. But if you take, there will be the correlation. Consumption and income. So consumption may have its own pattern. Income may have its own pattern. But if you see, long-term both have the relationship. What we mean, I mean by that, let us say that happens. It could happen. Your income has increased, but this time you may not have increased your consumption. But it's not that always you will not increase the consumption. There will be possibility where your income has reduced and your consumption has increased. So ultimately in the long term, what will happen? Both these follow the same path. So there is the relation. That's what we mean by the point. Same the inflation, the money supply. There might be chance in money supply has increased, but there is no inflation. But sometimes it's not waste. In the long term, it should be there. So basically, if you remember, the MB is equal to P by equation. So if the money supply increases, price must increase given the V and Y. So in the short run, there might be chance the money supply has increased or decreased. There is no effect on the P. But in the long term, it cannot sustain. Both will be the and there will be the cointegrated relationship. That means if you wanted to test whether MB is equal to PY is valid or not, we can take help of the nothing but the cointegration. So the economist point of view, cointegration is the statistical expression of the economic equilibrium relations. What we can say. Let me know here, because after that it becomes a little more intensive. So have you understood the concept, intuition of the cointegration? Because if you understood this, then there is no difficulty of that. Have you understood the intuition? What is the cointegration? When we say these series are contiguous, what we mean basically we mean both will have some underlying relationship which basically moves both these to one, isn't it? Let me give not related to this some thing which you can use. If there is a co-integration, you can think of the Amazon reverse banks. So one is moving this side. So what could be there? Either this can pull this side so that only width remains same, or that maybe this pulls this side. So either one has to pull another, then only we will have width the same. Otherwise, the different tributary may be there. That's why we call what we call in econometrics term, that is nothing but the Granger probability. So if there is the cointegration, there must be at least one way causality. There must be, there is compulsory. If the series are cointegrated, there must be at least one way Granger. There could be feedback, but at least one way Granger. Either X causing Y or Y causing Y X. If there is a cointegration. Now, the panel cointegration test, there are the, yeah. No. Basically, we test when there is the non-space. So there is the three different tests: Pedroni, Cow, then Western, we have the 2014 and 2007, 2008. Then recently we have 2025 this year only. So I'll be talking about the first Pedroni, then Western, then this year's test, 2025 content, because all three have the different thing. In Pedroni, what we are doing here, basically, this is the regression equation we have. So basically, what this YIT is the non-stationary, this XIT is the non-stationary, isn't it? And we wanted to see whether this epsilon IT, this is stationary or not. If it is stationary, that means there is the cointegration. If it is non-stationary, that means there is no cointegration. That's how we will conclude. So this is the explanation. What are the things? Alpha is nothing to fixed effects, heterogeneous intercept. Delta is the time trend. Beta is the cointegrating slope, coefficient, or can be heterogeneous. So this is the residual where basically we'll test about the stationarity, and that will tell us whether these are cointegrated or not. So here, this is if epsilon t is I0, that means stationary. We will say YIT and XIT are cointegrated. This is the long-term relationship. In the short term, there may be difference. Now, the null hypothesis, no cointegration. No cointegration means epsilon of IT is non-stationary, isn't it? That's only. Now, the Pedroni has given in total 7 tests. In total, they have given the 7 tests. One is the within dimension. Then those 7 has been grouped within dimension and between. So let us first clear it here. What is the within dimension of panel statistics? What is the between dimension of statistics? So within dimension, basically what we do, you have heard the term of the pooled regression. So within dimension is nothing but basically pooled regression. So the pool data along the both I and T, same as the pool regression we do. We do that here and we get the statistics. So these statistics are known as the within dimension or the panel statistics. Where is the between dimensions? Basically, we do create the test statistics for every cross section. Then we take the average of those test statistics, what we call the between dimension or the group statistics. And you have to take the inference or the based on the result of these both this, because both will have the different implications. So what we have 1, 2, 3, 4. So here we have the 4 tests. Here we have the 3 tests. So when you conduct Pedroni test, you will get the several results. Then here one interesting thing comes that some test will tell you there is the cointegration. Some test may tell you there is no cointegration. Then how we take the decision at the end? All statistics are based on the residuals from estimated panel cointegration. Only differ how we collect that. That's the only difference we have. No cointegration residuals follow I1. Cointegration residuals follow I0. That's we have. So how we will. If the test status is less, that is the more negative than the critical value, then we reject the null. That means there is cointegration. Interpret evidence of cointegration between YIT. Use multiple statistics, both panel and group, for the robustness. Just picking one statistic and saying there is a cointegration could be misleading. So here I told you both these are the differs. Why we are considering group statistics allow heterogeneity in cointegrating vectors. So that beta I could be different for the different cross-sectional units. However, the panel statistics import the more homogeneity. Why more homogeneity? Because we are pooling. We are assuming all the relationship of the same, and we are treating all the data same. That's why we are assuming homogeneity in the panel test, and group statistics say no, beta I could be different for the different statistics. Then this is the Western error correction norm. So here what we are assuming this phi I with beta IT. Simply, we are doing nothing, but we are changing this middle part, that is the error. So delta is the first difference of the dependent variable. Alpha unit specific fixed effect, that is the heterogeneous panel. Error correction coefficient, that is the speed of adjustment short-run dynamics for respective variables, epsilon yt errors. This now we are looking basically this part, error correction. What is error correction mechanism? It says this. Think of this way. Let us say one child has spoiled, isn't it? So he got scolded by mother. Then it could be possible, whatever the bad habits he has, he may stop it doing from the next day, isn't it? Possible. It could be he may stop little that day, maybe some next day or some. Ultimately, he comes to the normal behavior. So here the relationship I'm looking for the mother's scolding and child's behavior. So what we call it speed of adjustment, how quickly he comes back to the normal behavior. If he comes back to normal behavior, that means there is the correlation of mother's scolding and its behavior pattern change. There is the significant relationship. If that is not significant, that means there is not at all relation. There is no co-integration. That means if there is a significant, that means phi I should be significant. And only we can say there is the error correction mechanism. If error correction mechanism, that means there was a short-run deviation his behavior, but ultimately he came to the normal behavior, isn't it? That's what we say. If now phi I is significant, that means this error correction mechanism is significant. So in there could be short-run deviation, but ultimately in the long run, it will come to the original relationship, original path. That means there is the continuity. So in this case, we focus on this phi I here. So here, if phi I is less than 0, the system corrects back to the equilibrium. Remember, if phi I will be more than 1, then that shock will be more larger. The deviation will be more larger rather than coming back. If it is 0, that means nothing is going to happen. So null hypothesis phi I is equal to 0. That means there is no cointegration for all the cross-sectional units. All the cross-sectional units, there is no cointegration. Then the alternative hypothesis, this we have. Then we have the two tests, the group mean test and the parallel test. Group mean test, average of individual statistics of phi I, average ADF taper suitable when assuming heterogeneity in the cointegration relationship. Again, the panel test is nothing but the pooled test, not the same like the Pedroni V. So how to estimate the ECM for each unit I, then obtain the coefficient phi I, then compute the test statistics. Aggregate T statistics across panel. This is the GT, PT is the T statistic from the pooled model. That's what basically we do. Based on that, we will do. So here we use the bootstrap critical values to account for the cross-sectional effect. So let us say sample out. We have this. If the p value is there, the reject null of cointegration. This significant GT, at least some unit exhibits the error correction term. Significant p panel as a whole is cointegral. That's how. Yes. This is the Banerjee and Kajan Sylvester 2000 overview test we have. It is the 225 test. Where they have incorporated to the structural break into their consideration. With the caveat here, this test computation is not possible right now in Stata because this paper came this year only. But you can use, if you have the access of MATLAB, you can use the MATLAB to conduct this particular test. So here in the hands-on, I will not show this test. Theoretically, I'm showing basically what is happening. It is available in MATLAB. Someone is wants, they can use the MATLAB to conduct this. Right now, the code is not. So to writing this code, it takes time. So it's some people may write. If you are very conversed in this data, you can write it. It's quite easy. So What is extends? Only extension here, we have the break test. So, and how incorporated? They have followed the same by and parent method to incorporate into the final structure test. So this is the Cointegration model they have. So now what they have, this extra term they have added. That's what they have done to account for the unit structural break. Others remains the same here. Otherwise, everything is same. So extend to ACM including this particular term. So YIT minus beta XIT. Now we add one more term here to account to the structural break. I the same. Other test status, everything remains the same here. Here we did the null hypothesis, no contribution even with the structural. So only that part we have added here. So to come to the final exhibit, stable long relationship despite parameters. So despite structural, there is the Cointegration we can. So that's about the unit root test and Cointegration. So in this, anyone has any questions?